All right, in this screencast, we are going to be looking at how you can estimate the osmolarity of a tissue, whether it's plant or animal or whatever it is, when you bathe it in a whole bunch of different hypo and hypertonic solutions. So this is how you can tell what is the concentration of a particular solute within a tissue. The tissue we're going to use in this example is potato. That's a really common lab to do, is to find out what is the sucrose concentration. In this case, we're going to do it in molar, to find out the osmolarity of sucrose of a potato. So we assume that there's actually some sucrose within a potato itself. They're relatively sweet. They're a starch. And so we want to know what is the osmolarity of sucrose in a potato. That's how a lot of things get stored. So we're going to take a whole bunch of cores of this potato. We don't want the outside because it's hard for water to move in and out. We're going to take a whole bunch of cores of this potato. We're going to try to get them uniform in size, but it's not going to be perfect. And then we're going to put these cores, we're going to weigh them, and then we'll put a bunch of different cores into 6 different solutions. And those solutions are going to range from like 0.0 molarity, like distilled water, all the way up to like a very strong sugary solution, like a 1.0 molar solution of sucrose. So we know that in the 0.0 in the distilled water, we're probably going to see that to be a very hypotonic solution to the potato. And we're hoping that the 1.0 sucrose molarity is a very hypertonic solution. What we're trying to figure out is which solution in between would be isotonic to the potato. Because if it's isotonic, then we can infer whatever that solution is would be the osmolarity of the potato. All right, so to figure out we need to be able to take the mass, because we know that the potatoes are going to lose or gain mass depending on if the solution that they're soaked in is hypo or hypertonic. So we'll put it in all these solutions. So we've got these potato cores in there. We've weighed them before. We're going to let them sit overnight, and then we'll weigh them again. And here's the data that we collected initially. So we have an initial mass of the potatoes that we put in each of these solutions. So, 2.5, 2.7, 2.9, 3.2, 2.6, and 2.8. So the initial masses for each of those sucrose solutions. And then after they sat overnight, we'll blot them off and dry them, as best we can, and then weigh them again. And we're going to get a final mass. So you can see that in some of these, like in the 0.0, we actually saw it gain mass. We would expect that because we would think that the pure water would be a hypotonic solution. And we would expect it to lose mass, which we see here. Here's the initial and the final. We would expect that it would lose mass in the very strong 1.0 sucrose solution. So that did kind of what we were looking for. So we've got them gaining mass here and losing mass here. So now we need to figure out, all right, so which one is more isotonic? Now it's not perfect. We can see the numbers didn't give us the exact isotonic solution. So what we need to do is calculate the percent change in mass for each of these cores, because the percent change in mass is really important. Because if one of these potato cores is smaller, like so this core is smaller than this core, if this core gains a whole gram, that is a lot more than this one, the one above it, gaining a gram. It would be like if you had a mouse and a polar bear and they each gained a kilo, you wouldn't notice the kilo gain on a polar bear, but you sure would on the mouse, right? So instead of just comparing the change in mass, we're actually going to compare the percent change in mass to make it more equitable about which way the water moved. So to calculate percent change in mass, here's the equation: final mass minus initial mass divided by initial mass times 100. So doing it for this first one, we've got 4 is our final, minus 2.5 is our initial, divided by 2.5 times 60, or times 100 gave us 60. So this is where I would put 60, and I would do that again for each one of the sucrose solutions, and this is what we ended up getting. So now you can see in these two solutions, it gained mass. In these solutions, it lost mass. So we can assume that the osmolarity of a potato is probably somewhere in between 0.2 and 0.4. You can then take this and you can graph it. And when you graph it, you see where it crosses 0 should be, like with a line of best fit, or if you connect the dots, should be where the that line should indicate that there's no change in mass. This one with the line of best fit, it shows 0.4, but we probably know it should be a little bit further over here. So possibly I would connect these dots and say, oh, well, it's 0.3 something. So that indicates the isotonic solution. So the osmolarity of the potato should be where this crosses 0. All right.